A cloudburst is a sudden and extremely heavy downpour in a very small geographical area. Imagine a massive water balloon bursting in the sky. That is what a cloudburst feels like on the ground. The India Meteorological Department defines it as unexpected precipitation exceeding 100 millimeters, over a localized area of about 20 to 30 square kilometers. This is not your typical heavy rain. It is a concentrated, violent, rapid release of water that the ground just cannot absorb quickly enough. The sheer volume of water unleashed in such a short span transforms gentle streams into raging torrents and stable slopes into deadly landslides, making it one of nature's most destructive and swift phenomena. These events are particularly notable for their suddenness and intensity. A cloudburst offers virtually no reaction time. The immense force of the water, combined with the debris it gathers, boulders, soil, uprooted trees, mud, creates a destructive slurry that can sweep away entire settlements, roads, bridges, agricultural lands. This characteristic makes cloudbursts a significant hazard, especially in mountainous regions, funneling the water and debris into narrow valleys with devastating consequences for the people and infrastructure below. Understanding this phenomenon is crucial, especially in the context of the Indian subcontinent's unique landscape. Uttarakhand, often called Devbhumi, the land of the gods nestled in the lap of the mighty Himalayas. Rugged steep terrain with high peaks and deep valleys, swift-flowing rivers like the Ganga, Yamuna, and their numerous tributaries. Part of the Shivalik ranges, and the greater Himalayan ranges, geologically young and tectonically active, prone to weathering and erosion. Loose soil and scree-covered slopes, fragile landscape and dense river networks, inherently vulnerable to water-induced hazards. Steep valley gradients act like funnels. Similarly, Jammu and Kashmir with Ladakh forms India's northern crown. Topography varies from the fertile plains of Jammu to the Pir Panjal and the Kashmir Valley. Ladakh is a high-altitude cold desert. Young folded ranges, seismically active and erosion-prone. Glaciers feed major rivers like the Jhelum and Chenab. Valleys collect flash floods and debris flows from cloudbursts. Population growth, tourism, and increased construction in sensitive zones. Roads carved into unstable hillsides and hotels by riverbanks increase risk. Unregulated development weakens slope integrity. It also obstructs natural drainage paths. When a cloudburst occurs, man-made structures are often the first destroyed. Understanding this complex geography is the first and most crucial step. The primary reason for the high frequency of cloudbursts in Uttarakhand and Jammu and Kashmir lies in a phenomenon known as orographic lift. This occurs when moisture-laden air masses are forced to rise. During the Indian summer monsoon from June to September, warm and humid winds travel from the Bay of Bengal and from the Arabian Sea. As these massive air currents reach the Himalayas, they are blocked by towering peaks and compelled to ascend. This forced upward movement is the critical first step, leading to towering, vertically developed cumulonimbus clouds. These are immense, dense, packed with extraordinary moisture, holding vast quantities of water over a small area. The specific topography of the Himalayan states traps and concentrates this moisture. The deep, narrow valleys and interlocking ridges create an atmospheric trap. Monsoon winds get funneled and prevented from dispersing. The cloud grows vertically until its holding capacity is breached. Interactions between weather systems can exacerbate the situation. Sometimes monsoon moisture meets a western disturbance. This convergence can make the atmosphere unstable and trigger extreme precipitation. The result is sudden, catastrophic release of stored water onto the small area below. A perfect storm for devastating cloudbursts in Uttarakhand and J&K. The combination of monsoon, orographic lift, valley trapping, and system convergence creates recurring hazard, making cloudbursts a recurring and deadly hazard in these regions. To understand a cloudburst in simple terms, look at the cloud itself. The responsible cloud is typically a cumulonimbus. Imagine a giant vertical tower in the sky, full of energy and moisture. It forms when warm, moist air rises very quickly from the ground. That rapid upward movement is called an updraft. As the air parcel climbs, water vapor condenses into droplets. Droplets form. Ice crystals form at higher altitudes. Powerful updrafts hold droplets and crystals suspended. Inside the turbulent cloud, droplets collide and merge. Coalescence. Updrafts act like a floor holding an enormous suspended reservoir of water. A cloudburst happens when that support suddenly fails. The whole volume collapses and falls almost instantly. It's not gentle rain, it's a massive sheet of water, sometimes accompanied by hail. It descends with tremendous force over a very localized area. Precipitation rates over 100 mm per hour define a cloudburst. Steep mountain slopes can't absorb this water. Runoff is immediate and gains momentum downhill. It picks up loose soil and increases erosion. It picks up rocks, even boulders. Runoff transforms into destructive debris flows. A cloudburst is a catastrophic failure of atmospheric mechanics, not a literal explosion. But its aftermath is violent and fast-moving. The Himalayan regions of Uttarakhand and Jammu and Kashmir have a tragic history of cloudburst events. One of the most catastrophic incidents in recent memory was the 2013 Uttarakhand disaster. On June 16-17, 2013, a series of cloudbursts struck near Kedarnath. The Korabari glacial lake breached its moraine dam, unleashing a wall of water, ice and debris down the Mandakini Valley. Entire settlements like Rambara were wiped out. Kedarnath town faced unprecedented destruction. The official death toll exceeded 6,000, many more were missing. The disaster exposed unpreparedness and the dangers of unregulated construction. In August 2010, Leh suffered nighttime cloudbursts that sent torrents of mud, water and boulders through the town. Homes and people were buried while they slept. Critical infrastructure was destroyed. The disaster claimed over 200 lives and left thousands homeless. More recently, in July 2022, a cloudburst near the Amarnath cave triggered a massive flash flood. Thousands of pilgrims were in the narrow valley. Tents and facilities were swept away. At least 16 died and dozens were injured, a stark reminder of risk during mass gatherings. These incidents serve as critical case studies for improving early warning and regulation. They highlighted the need for stronger early warning systems and land use regulation, and for concerted disaster response capacity building. The scars of 2013 are still visible in the landscape and memory. It underscored the dangers of illegal construction and over-tourism in fragile zones. The socioeconomic impacts of cloudbursts are immediate and often long-lasting. Vulnerable communities are pushed deeper into poverty. The most direct impact is the tragic loss of life and injuries. Entire families can be displaced, losing homes and possessions in minutes. Agriculture and tourism-dependent economies suffer severe blows. Infrastructure damage cuts off access, hampering relief for days or weeks. Reconstruction costs run into billions, burdening state and national exchequers. Tourism revenue collapses, livelihoods vanish overnight. Families often take on debt to rebuild, trapping them in cycles of vulnerability. Communities are torn apart, social fabric weakens, compensation is often delayed and insufficient. Before full recovery, another event can strike, repeating the cycle. Long-term intervention, sustained aid and resilient planning are essential. Otherwise, communities remain trapped in a vicious cycle of poverty and risk. The environmental impact of cloudbursts on the fragile Himalayan ecosystem is severe. Debris flows and erosion cause irreversible damage. Fertile topsoil formed over centuries is stripped away. Flash floods uproot thousands of trees and destroy forest cover. Rivers are choked with silt, reducing water-carrying capacity downstream. Aquatic life suffers, water quality declines sharply. Geomorphology is altered, new channels are carved in hours. Landslide-dammed lakes form, precarious and prone to sudden breach. These dams can breach and cause catastrophic downstream floods. Environmental degradation creates a feedback loop of vulnerability. Reforestation and soil conservation must be part of long-term risk reduction. The topic of cloudbursts is highly relevant for the UPSC Civil Services examination, particularly GS Paper 3. It links disaster management, environment, economy, science and technology, and security. Candidates should discuss technological tools like Doppler radars, nowcasting, and GIS. Also governance aspects, NDMA, State Disaster Response Forces, risk-sensitive land use planning. Answer tip: link geography, climate change, development pressures, and governance in a holistic way. Use case studies, Kedarnath, Leh and Amarnath, as examples. To mitigate cloudbursts, a multi-pronged approach of prevention, preparedness, and robust response is essential. Enhance monitoring, expand Doppler radars and automatic weather stations in the Himalayas. Nowcasting can provide hours of warning. Couple tech with community alert systems. Mainstream risk reduction into development, strict EIA, zoning and enforcement. Promote reforestation, check dams, terracing and slope stabilization. Train local youth in first aid, search and rescue, and form village disaster committees. Build multi-purpose shelters stocked with water, food, and medical kits. Cloudbursts are formidable, but proactive integrated strategies can reduce risk. Combine technology, sound policy, strict regulation, and community involvement. For a UPSC aspirant, learn the definitions, link causes and impacts, and recommend practical mitigation.